All right, math minions and pre-cal peeps. We're going to continue talking about solving log equations. This will be our day 2. Just as a reminder, this week things are kind of weird for us, but we are going to have an assignment to do, and if you need help on that assignment, I'll plan on being available in the tutoring meeting through the link in Canvas the last 2 periods of the day. Okay, and a little bit after school. So if you need some help with some of this stuff, and if we're not meeting, you can always get help by using that link the last 2 periods of the day here the next several days. Okay, now we've looked at a couple of solving equations involving logs over the last, from Friday's video to today's assignment, and then in tomorrow's video. So what we're going to deal with now really are situations where we have to use our laws of logs. We haven't had to do them on these, right? These, the type that you have just an exponential function where x is up in the exponent. All you really have to do is get that base by itself and then convert it to log form, or you apply the inverse or apply log base to both sides. Okay. The other type, and we're going to look at another set of these today, is if not all terms have the log on them. If not all terms have log on them, then your goal is to get that log part by itself, and then either convert it to exponential form or use that exponential base as the inverse. Okay, get it to do this. All right. Some that we're going to look at today are where all the terms have log on them. If all the terms have log, then our goal is to get log equals log. We're going to use our laws to get the left side condensed and the right side condensed, and then we get to ignore that log part. Kind of like how when we solved exponentials, when we got the base to be the same, then we ignored the exponential base and just looked at those exponents. Same idea. If we can get the log sides, the log parts to match, if I got log on the same side, on the left side and log on the right side, then I get to ignore that log part and then just solve that equation by setting the arguments equal to each other. Okay, again, we'll look at those. Those are the types that we're going to deal with today as we move into this. We are going to take our test on Friday, and some of this stuff is going to be on there, so let's get to it. All right, here's my first type. Okay, here's 1 right here. Okay, notice that this type right here doesn't have log on every term. This 1 does not have a log. So what we're going to do is we're going to use our laws to condense this side, right? Remember how this condenses. If I have subtraction can condense to division. Okay, all the ones that have negative log means that this part goes in the denominator. So we're going to condense this down to just 1 log. So it's log of 7x plus 2 over 3. Now remember, if there is no base, it's understood to be base 10. That's going to be important to us here in a minute. But that's something you're going to have to remember as we're doing this. You look at that base. That base is important, okay? And then this side doesn't have log on it. It can't do anything with it. It's just a 1, okay? This is the point where if I get it to be log equals a number, I've got the log part by itself now. I'm going to, I can't ignore that log. I have to convert that log, okay? Like I showed you, when I have log form, I can turn it into exponential form, and remembering that log bases and exponential bases undo each other. So since I want to get rid of this log base 10, and I can't ignore it because I don't have log base 10 on this side, then if I want to get rid of log base 10, I'm going to make this whole left side an exponent of a base 10, and I'm going to make the right side an exponent of a base 10. That way this 10 to the log base 10 part goes away, and I end up with 7x plus 2 over 3 equals 10 to the first power, and 10 to the first power is just 1. Well, now we're just solving a regular equation. If I'm going to get x by itself now, I'm going to multiply both sides by 3 to cancel out that division. And so 7x plus 2 equals 30. Now minus 2. Again, this is all normal now, right? We know how to do this. We're good at this. Subtract 2 from both sides, and this side becomes 28. And then finally, we can divide by 7 on both sides, divide by 7, and x equals 4. Okay, so that's what we're going to do. If not everything has a log, we want to use our laws to condense, and then get rid of this log base by using an exponential base to both sides. All right, again, keep in mind, we can always go check this. I can go type this in my calculator and substitute a 4 and see if I get a true statement. Okay, we can do that. All right, I do want to show you with Desmos real quick, if I can get Desmos to get fired up, how to get logs in Desmos, okay? Just to show you that real quick, because I realized I didn't show you all in the video of the last one. But if you go to functions in Desmos, functions, and go to miscellaneous, we've gone here before, go to miscellaneous, and right down here is your log base. So if you want a log base 10 of, and we want to check our answer, what was it, 7 times 4 minus 2, no, plus 2, close that up, and then do minus, let's just go grab log, we don't need the base 10, minus log of, what was it, 3. Notice that we get equal to 1, so we know that our answer is correct. But you go to functions, go to miscellaneous, here's your log, that's log base 10, and if you want a different base, you use that one. Okay, we won't have access to our calculators in class today, and you probably don't have access to them as you're going to be working these out wherever you are throughout the day and the next several days. So use Desmos, here's your log, regular log base 10, here's log base, whatever you need. Okay? All right, I realized I didn't show you that, so I wanted to make sure I do that. All right, let's do another one. Okay, now notice everything here has log. And again, it's log base 10, but it doesn't matter. It could be that they're all log base 5. That really doesn't matter. As long as they all have the same log base on them, our goal is the same either way. If everything has a log, all terms have log, then we're going to try to get to be log equals log. Okay, you might want to copy this down into your notes. All right, just so you keep track of what do I do. All right, so I'm going to use my laws of logs again. Okay, remember subtraction means we get to condense it down to division. Get to divide this and this. Okay, so I have log of 2x over 5. The negative log means it goes in the denominator. And this side is just log of 30. Okay, and now since I have log equals log, I get to ignore the log part. Okay, it's like I'm doing 10 to this power and 10 to this power. Notice that's going to end up going away. So essentially I get to ignore that log part and say 2x over 5 equals 30. All right, well, let's solve it. How do I solve that? Well, multiply by 5. So I get 2x equals, what is this, 150. Then divide by 2, divide by 2. This part's not new. This part's easy for us. We have to get to the point where we get to this part, and that is we use our laws of logs to condense, and once I see that I have log on both sides, I get to ignore that log part. Because essentially I'm applying that same base. This is log, so it's a base 10. If I use an exponential base 10 to both sides, it will go away. And then I'm just solving that equals that. Okay, multiply by 5, divide by 2. And again, we can go check that. Type it into Desmos, 2 times 75 minus, or sorry, log of 2 times 75 minus log of 5, and it should equal whatever log of 30 is. Okay, one last one. I want to do this one because it doesn't have log, and I want to remind you how you're going to do those. Remember, if you don't have log, your job is to get that base by itself. So I just want whatever the base is by itself with x up in the exponent. Okay, so that's what I'm going to do here. I'm going to get that base by itself. I can't do anything with this right now. I still have e to this. So this e is the base that I'm trying to get by itself. Well, how do I get that by itself? Well, I got to get rid of the 30. How do I get rid of 30? Since it's 30 times e, I'm going to divide both sides by 30. Okay, so let's do that. What is that? 145 divided by 30. 4.833. So I have e to the 2x plus 2 equals that number. Let's just go ahead and call it 0.833. Okay, and so now what do I do? Well, now I have to undo this exponential base. Remember, log bases undo exponential bases. So we're going to do log base e. Do you remember what's the same thing as log base e? Yeah, it's called the natural log. So if I do log base e of this side, or I do natural log of this side, all I'm going to end up with is 2x plus 2. And so I'm going to go calculate the natural log or log base e, your choice, natural log or log base e of 4.33. Let's go ahead and use Desmos because I'm sure that's what you're going to end up having to use while you're doing your work for this assignment. Okay, here's your natural log, here's your logs over here. Remember, you pull up Desmos and it's right here in functions. We're going to do natural log of 4.3. Actually, let's do the whole thing. 145 divided by 30. Okay, if I do that, it should get the same thing as natural log. It should be pretty close anyway. Natural log of that 4.833. Yeah, it's pretty darn close. Okay. But that's what we end up with, and let's see what else we need to do to finish this problem. So we ended up with, what was it? 1.576. 1.576. Okay, now I'm solving this now. Solving for x means subtracting 2. Okay, so let's just take that number there, and then we're going to subtract 2 from it. Let's just tack on a minus 2 here. Okay, and so we take that number right there, and we're going to take this whole thing and we're going to hit divide by 2 to finish it up, right? Because that's our next step. And so we take this whole thing minus 2, and then whatever that is, that's a negative point something, but we're still going to have to divide by 2 to finish it up. And we ended up with negative 0.212. Negative 0.212. And that is our solution. But I wanted to do this one because it's not a log, right? It's an exponential base. And so we're going to use log bases to undo exponential bases. But in order to do that, the first thing we need to do is get rid of any multiplication first. I can't get to this exponent until I get this base by itself, and I can't get that base by itself until I get rid of that 30. So get rid of the 30, divide by 30. Pull up your Desmos and use your log base e, or you can do the natural log. Log base e is natural log. Okay, they're not inverses, that's what it is. All right, and then after that, it's just solving. Subtract 2, divide by 2, and you end up with that number right there. Okay, you can do it piece by piece along the way and just keep track of it in Desmos, but these are the 3 types we need to be able to solve for our test. Types where x is up in the exponent, where we have to get the base by itself and then undo the base with a log base. If it's an e, you can use log base e. If this base was a 3, you would use log base 3. You have types where you have logs on both sides. You try to get log equals log so that you can ignore that log. And then you have types where not everything has a log, so you use your laws to condense, and then you undo your log base with an exponential base. Those are the 3 main types we need to be ready for on our test.